In this lecture, I want to talk about polar or cylindrical coordinates. Polar coordinates are basically a different way of describing a point or object or equation in space. The way we're going to address this is by looking at our Cartesian coordinate system we have here. We have our x-axis and our y-axis, and we can put a random point in the middle here, let's say around here. Now, we know from before that one of the easier ways to describe this point is by dropping an orthogonal line down to the x-axis to give us our x value. We'll call it x. And another orthogonal line over to the y-axis to give us our y value, which here we'll call y. So we can describe this point as having the value x, comma, y. And we can also describe this point in terms of a vector. We call it the position vector, or the r vector. And this r vector goes from the origin here out to the object itself over here and describes its position, sort of like this. So we can describe this r vector as the vector going to the point x, comma, y, or we can describe it as a vector with length and direction, saying that it has the magnitude or length of x, meaning this length in the direction of x, plus the length of y, or this length in the direction of y. Now keep in mind that any position vector can be described this way. It can be described as the position vector that goes to the point xy, or as the position vector with the magnitude x in the direction of x and the magnitude of y in the direction of y. So we've seen that we can describe this point using the variables x and y, but we can also describe this point using two other variables interchangeably, using the variables r and theta. Now r and theta, just so you know, are not the same thing as the r vector, and we're not going to use them as vectors. In fact, r and theta, just like x and y, are just magnitudes. They're only variables. We're talking about lengths, magnitudes, distances here. What are r and theta? Well, r is the length of the position vector r that we talked about before. So if you look for the length of this position vector, that equals r here. And theta is the angle, the measure of the angle of that same position vector. If I have an equation set out in terms of x and y, and I want to move it into terms of r and theta, I can do that pretty easily, and I can do the same vice versa. The reason is that there's a fixed relationship between these two sets of variables, between r and theta and x and y. The fixed relationship means you can switch back and forth between coordinate systems really easily as long as you know the formula to get you there. Let's say my equation is in terms of r and theta, but I want to have my equation in terms of x and y. Well, x equals r times the cosine of theta, and you can see why if you look up here, and y equals r times the sine of theta. And we should put this in your formula sheet. We also have formulas to switch from x and y into terms of r and theta. As you can see here, r equals the square root of x squared plus y squared, and tangent of theta equals y over x. I want you to make an effort to remember these formulae going forward, because we're going to use them a lot.